What's up? Welcome to this mess. Oh, wait a minute. Someone's calling me. Yes, hello? What? I paid my car insurance yesterday. What are you talking about? No, I paid already. No! Kill yourself! No!
Alright, so we have three main functions in trigonometry. Sine, basically the wavy one, cosine, the other wavy one, and finally tangent, the middle child. But before we can even begin to understand what those functions are and what they do, we even need to understand what they're based on. All trigonometry functions are used in the context of triangles. Crazy, right? Trig, triangle, oh, that's crazy. Yeah. So essentially the functions tell you how much bigger one side is compared to the other. Essentially just the ratio between the sides is what we usually say, okay? But to do this, they need one more thing. Actually, technically two more things, and technically three more things, because they need all the angles inside of the triangle. You need to know all of them, basically. So if you have a triangle where you have one right angle, the right angle is required. You have to have a right angle triangle, else you can't do it. But thankfully, if you have a triangle of any kind, you can just split it and boom, you have a right angle triangle. Or actually, you have two right angle triangles. So all you need is one more angle known, and boom, you can use all of them. Because if you got two of the angles, you can just do 180 degrees minus the rest, and boom, you have the final angle as well. So you essentially just need to know all the angles in the triangle. Okay. It needs to be a right angle triangle, and you need to know one more angle. Okay. Speaking of right angle triangle, that's 90 degrees. But what is a degree? We know Celsius and Fahrenheit, for example, maybe Kelvin as well. They are all degrees. But they don't mean degrees in terms of angle. They mean degrees in terms of scale of temperature. There are other degrees as well, but I mean, what is this little circle thing we see on the top of numbers? For example, 30 degrees with a sign. Like what? Okay. Well, it means degree. But what does it actually stand for? So turns out the sign circle, basically to the power of a circle, it looks like, but it's actually just a circle, just is a number. Pi divided by 180. What in the actual tarnation is that abomination doing in degrees? It's just a number, just like mole. You know, mole in chemistry, it's the amount of atoms or something like that in 1 gram of hydrogen, I think. Avogadro's number, basically 1.6 or I don't know, to the power of minus 23 or to the power of 22 or 23, I don't remember. But this is exactly the same thing. So when we say I have 1 mole of hydrogen, that's saying I have some amount of hydrogen atoms. But when we say I have 30 degrees, that just literally means I have 30 times pi divided by 180. Why times? Because this little sign there, the circle, it's just a symbol, like x and stuff like that. It's a variable, but not actually a variable. It's a constant. Where does this come from? How do we know it's pi divided by 180? And why? Well, it's a long story, but we skip all the details and just go to the basis of it and work our way up there. So you might remember the formula for the circumference of the circle. That means the line, if you try to draw a circle, you go around like this, yeah? But how long is the line? That's the question. So let's say you know that from the middle point of the circle all the way to the edge to the line that you drew, that is called the radius, okay? That no matter where you place it, it's always called the radius of the circle. So let's say we have that radius and it's 1. So the distance is 1. R is 1. Well, what's the formula? It's 2 pi times r. Okay? So you're saying I'm just going to multiply this radius times 2 pi and I get the circumference. And yeah, that's exactly what I'm saying. And what does this have for a connection with degrees? Well, remember pi divided by 180. And let's just say a circle has 360 degrees, okay? 360 degrees. And we know that if we times r with 2 pi, we get the entire circle. Well, if degrees is just pi divided by 180, how would we write 2 pi? Well, try 360 degrees. 2 pi should be the same thing as 360 degrees. Okay, so we have the sine 360 degrees. Okay, so we multiply 360 degrees by pi divided by 180. We see that when you multiply and then divide, or in the other order, it basically cancels out. And because the multiplication is twice as big, it gets 2 pi divided by 1. 2 times pi divided by 1. Divide by 1 doesn't do anything. You just get pi. And 2 times pi is the answer. So it turns out 360 degrees is the exact same thing as saying 2 pi. So the reason why we have degrees is literally because of the formula of the circle. If you say degrees, you're saying how long is the line you're drawing. And what do you happen to do when you're drawing degrees? Well, you're drawing a line that's a circle. Between the two sides you're drawing there, you're drawing a line between like that. That's all you're doing. And 360 degrees and stuff like that is just describing how long that line is. And, when you do the degree sign, it's called degrees. And when you don't, it's called radians. So if you just write a number, you have to write rad after, because degrees are actually just rad. Now, you might be asking, what does the calculator think of this? They just ignore it, right? Or they change the formula entirely. No. When you have your calculator, the base settings, the default settings, should be, on most calculators, that it uses radians in angles. So you plug in any trigonometry function, it's going to use radians, okay? When you go to the menu and change that to degrees, it's actually just telling the calculator to, convert this from degrees to radians before you do anything. And so now we know that. And we just need to know what are the functions, what are the definitions of the functions. How do we use them, perhaps? Okay, so before we explain how to use them, we'll just go over the definitions, and in this case, the complex definitions, because I can't bother inputting every single definition there is. But don't get worried. What you see in a short amount of time will not be the stuff you're learning right now, or what you're forced to learn, probably ever. It's an option, but you definitely won't have to, because it looks dumb. Okay. So, are you ready? You're going to see some complex definitions on the screen right now. Those are the complex definitions. So, you could, by hand or with a calculator, plug in that, and you figure out the sign of the value you want to get. But that would be stupid, and you could use you could just use the sine function instead. And there are shorter definitions. For example, the imaginary value from e to the I theta would be the same thing as just sine, and the real part of e to the I theta is just the cosine. But we're not going to use any of those. Relax, okay? All we're going to do is tell you which one is to be used when. And I'm going to do that with some animations and my good friend explaining these. And my good friend, the detective, who thinks he's Irish, explaining these trigonometric functions.
Whoa. I was not expecting it. Sorry. But when you're already here, why not try to learn some math? Alright, so we have a triangle that has 90 degree angle in it. And we also need to know one of the other angles. Now this angle we will call theta. Alright, so the closest side or the adjacent side to the known angle will be called A, as in adjacent. And then the opposite side of the known angle will be called O, as in opposite. And then the hypotenuse we will call H, of course. Now, the sine function is usually written with sine theta is the equivalent to O, as in opposite, divided by H, as in hypotenuse. What about the other functions, like cosine or tangents? Now, those are almost the same, just that they use other sides. But now I need someone else to take over.
So I'm not the one who's gonna be taking over, but we've got a professor from Wish.
Alright, I'll take over from here. Now we know the connection from the angle to the ratio between sides. Which means, if you know the angle and how long one side is, you can figure out how long all the other sides are. But what if you already have two of the sides? Not one, not all three, but two of the sides. And you want to figure out the angle for some reason. We don't know, but the question says so. Because, you know, mathematics, kinda complicated and kinda weird. They demand a lot and we don't even know how to answer most of it. Like, what are we doing with our lives? But back to the point. We have two of the sides. You usually only need to use arctan because that is what the information we get from the sheet, from the paper, from the text. But for later stages in math, as we are in currently, it pops up like that one side character in your favorite show that nobody likes, that we all would just wish die. So you have the opposite side and the hypotenuse. You know, the opposite side and the hypotenuse. But you don't know the angle. Let's say that the opposite side is 3 centimeters. The opposite side 3 centimeters. And the hypotenuse 5 centimeters. How will we get the angle from that? From this information? Well, if we look back at our cheat sheet, our cheat paper, we can see that the regular sine function gives us the opposite side divided by the hypotenuse. Stay with me. However, the regular sine function needs an angle, and we do not have an angle yet. Instead, we have to create a new function called arcsinus. All we do is swap the angle for the ratio between the sides. And boom! That's simple. That's simple. Now you can input the opposite side and the hypotenuse and get back the angle you want all along. Yeah. It's that simple, really. You just have to listen and like use your eyes for once and literally just take number for number and put it in the equation, you know. Very simple. And with that, we have figured out what the angle is. Really easy, as I said. You can think of arc as meaning angle or anti, depending on what you think will be more reasonable for you, more appropriate to you in your sense of thinking. But of course, as most things in math, fucked up, complicated, and outright horrible. There are different ways to write this down. Because no, this wouldn't be math if it was just one simple way. But trust me, it's easier than what you may think. You can write arcsin as asin or sin to the power of -1. All of these work and mean the same thing, but usually it's sin to the power of -1. Especially on your calculator, which we spend a lot of time on our calculator because we don't have the mind of a calculator to do math.
Oh fuck! You're back. Okay. Wait, don't go. There's still some more things we need to do. So for one, this is just a video explaining how to use them and what they are. Okay, just the trigonometric functions and the basics. But secondly, also very important, you need to learn how to use them in an actual problem, in a scenario. So I'm gonna go over one of them with you. A combination of sorts, and after that I'll give you 3 questions that you can answer on your own. All right, so I'll just say good luck. I'm gonna have some clips playing in the end, and yeah. All right, so we're gonna start by considering a double triangle, basically. On the left side we have a triangle facing upwards with a angle which is known 32 degrees, and then we have a right angle triangle up, and then the side on the top is 4, and we have on the bottom basically no info, but we can figure out the rest. However, right side triangle is facing the other way with the right angled triangle down this time, and the bottom length is 7. However, we want to figure out the angle X from the info we just got. So we'll start by considering a way to get back how long the middle line is. How long is the line in the middle? Well, let's look at the functions, see if there's any, functions involving those two sides. So we're going to look at sine first. So the formula is sine of theta is O divided by H. So in this case, theta is 32 degrees. That's the angle we're considering. So if we look from that perspective, what side is opposite? Well, it's the middle side. Okay, middle line right there. That's the opposite side. And H, that's the hypotenuse. That's the long side. So it isn't sine that we want, okay? We're going to continue. Oh, is it cosine? That involves the adjacent side, which is the side with the 4, and the hypotenuse again, so it's the long side. We want the middle line, the middle side, and the 4, okay? And is it tan? Well, turns out tan is O divided by A, which is the middle line divided by the 4, okay? So we now have a function that involves both of those sides. So we're going to duplicate that function. We're going to insert the 32 degrees. We're going to insert our known adjacent side, which is 4. And then we just have to do like an equation and solve it. Basically, multiply with A on both sides, which is the adjacent side. When you multiply and divide by the same thing, it cancels out. Boom, you can scratch away those A's and they're gone. And then we just do the same thing on the other side. And now we have the formula tan of 32 degrees times 4 is O, which is the opposite side. Okay, so now we have O, which is the middle line. We calculate, we plug it into our calculator. What is the value? And we get 2.499 and stuff like that. That's basically 2.5. So we're just going to insert that. Anyway, now we're going to set that value there. It's basically 2.5. And we're going to continue. How would we get x back? Well, we need some kind of function involving the middle side, the middle line, and the bottom line, which is 7. So we're going to check sine, okay? Sine would be O divided by H, which is 2.5, the middle line, perfect, divided by the hypotenuse, which is the long side. Oh, we didn't want that, okay. Cosine, that's A divided by H. Okay, so the 7 line divided by the long side. Okay, so we wanted the 7, but it isn't the hypotenuse. How about tan? Tan is O divided by A, just like before. Okay, so 2.5 divided by 7. Oh, okay. So that's the one we want. But using tan, that wouldn't work. We wouldn't get the angle. We would get the ratio between the sides. So we do like the professor from Wish told us to, and switcheroo the angle and the ratio. Boom, it's switched. And then we just replace the tan with an arctan. Boom, it's an arctan. Now that function, we plug that function in and we would get back the value. But first we need to plug in the values. The O, the opposite side, that's 2.5. The A, the adjacent side, is 7. Okay, so now we just calculate what is arctan of 2.5 divided by 7. Plug that into the calc. And we see that that's basically 0.344, but that's in radians. So we have to convert that to degrees. We just do the quick thing that I told you about. And that's basically 20 degrees. Let's see the solution. And it's correct. Let's go. Good job.
What are they doing? Ah! It's freezing outside. What the fuck? What is it playing? Is that Green Day? What is that? What is he doing? What is he
Do you have the time
guys?
to listen to me whine
Guys.
about nothing and everything about us?
Guys.
I wanna
Help,
those
please help. Please help.
melodramatic
It's freezing.
flows.
Guys. Guys.
Sometimes I get myself dressed. Sometimes a monthly effect on me. It all keeps adding up.
It's so sad.
I think I
What the fuck is he doing?
am I the paranoid? Or am I the
What is he doing? There you go.